Shopify is a company that helps customers build custom online storefronts. Shopify has built upon the same Ruby on Rails application since the founding of their business 12 years ago, starting with Rails 0.5 and moving all the way to Rails 5. MRuby is a lightweight implementation of the Ruby language. Shopify made the decision to use MRuby to allow customers to create custom scripts that are run every time a customer adds items to their cart. However, since MRuby was a language implementation that was not widely used, Shopify opted to post a bug bounty to the HackerOne bug bounty platform to find security vulnerabilities in their use of MRuby. What followed was a payout of over $500,000 as report after report flooded in of security vulnerabilities inside MRuby itself. There were so many reports that Shopify made the decision to sandbox the MRuby execution into separate processes and decreased the bounty awards by 90%. In this episode, Jeremy Jung interviews Daniel Bovensiepen about MRuby and the Shopify bug bounty program. I hope you enjoy the episode. Spring is a season of growth and change. Have you been thinking you'd be happier at a new job? If you're dreaming about a new job and have been waiting for the right time to make a move, go to hired.com/sedaily today. Hired makes finding work enjoyable. Hired uses an algorithmic job matching tool in combination with a talent advocate who will walk you through the process of finding a better job. Maybe you want more flexible hours, or more money, or remote work. Maybe you want to work at Zillow, or Squarespace, or Postmates, or some of the other top technology companies that are desperately looking for engineers on Hired. You and your skills are in high demand. You listen to a software engineering podcast in your spare time, so you're clearly passionate about technology. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $600 signing bonus from Hired when you find that great job that gives you the respect and the salary that you deserve as a talented engineer. I love Hired because it puts you in charge. Go to hired.com/sedaily, and thanks to Hired for being a continued long-running sponsor of Software Engineering Daily.
Daniel Bovensiepen is a core committer on MRuby since 2012. He designed and implemented the MRuby package manager, test system, documentation generator, and interactive MRuby shell. So first, I'd like to talk a little bit about MRuby. So Ruby is a programming language that is most commonly associated with the web framework Ruby on Rails. There's a lot of very large companies these days, such as GitHub, Twitter, and Stripe, that really built their business on using Ruby as a web programming language. However, MRuby targets a very different subset of the development community. So what makes MRuby a compelling target for software engineers?
Okay, so first of all, yes, there are more than one Ruby implementation. So when people like GitHub or actually also GitLab using Ruby, they most of the time use something called MRI or JRuby, which is both implementations, one in C and one in Java. And they are very performant and are very robust, but they both have a huge issue, and it's the size. And I do not want to call it clumsiness, but it's just a huge piece of software for both interpreters, which has grown over the years. And it's very hard to build actually small systems with these huge interpreters. So if you have something like MRI, you already start with several megabytes of RAM usage and a hard disk space, and JRuby is even bigger. On the other side, MRuby gives you the possibility to build extremely small systems. So we can actually build an MRuby interpreter in sizes of maybe 40, 50 kilobyte. So that's an order of magnitude smaller. Furthermore, this is actually possible because the MRuby is extremely modular. So we built an interpreter which you can actually customize. So usually if you use a programming language like Ruby or Java, you expect actually a specific standard library to be always available. And that's, of course, very helpful. But most of the time, you actually do not need all features. And MRuby gives you the chance to actually cut away all features you do not need. So, for example, it might be that you actually do not want to have file system support or network stack. That seems to, for most software developers, maybe a little bit strange. But if we look at microcontrollers, for example, you do not have a file system. So you should not have file system stack inside of your Ruby interpreter. That is just waste of space. And MRuby gives you the possibility to actually do that. So it's a flexible, very small Ruby implementation, which enables to build very small applications, which can run by itself, but which can also very nicely integrate it into other applications.
So you gave an example of installing an MRuby application onto, say, a microcontroller, where you're very resource constrained. Can you give an example of, somewhere that you would use MRuby on a microcontroller?
Yes, so one of the first examples where that actually worked was the so-called, maybe the audience knows the Arduino platform. So these very tiny hobbyist microcontrollers, usually they have something called an Atmel. So an 8-bit microcontroller, they are pretty small, and actually we cannot really port MRuby on these ones because they are lacking some specific hardware elements. But in 2012, I think end of 2012, the Arduino Foundation actually released something they call the Arduino Duo. And this is a microcontroller which has actually an ARM processor. So actually something like you have in your phone, but much smaller, so-called ARM Cortex M3. And these microcontrollers, they are still pretty small, have a very low power consumption, but we are actually able to put Ruby into these microcontrollers. So we're talking about a microcontroller which has 196 kilobyte of RAM and 96 kilobyte of RAM and 196 kilobyte of flash actually. And MRuby fits easily in it. And what I personally did was actually building a small little 3D printer some time ago, and also some other projects based on it. So that's more from a hobbyist point of view. But other companies, especially in Japan, they're actually using this kind of approach to build IoT devices. So the last couple of years, there's of course a lot of bullshitting about IoT, but there are some actually useful applications. For example, smart power sockets who measuring power, or light bulbs, which can be remote controlled. And this is applications where we fit very nicely in, and they're actually already in our implementations based on MRuby for this.
That's very interesting, because I've heard some people talk about using, say, JavaScript with microcontrollers, but I think in that context, I believe the JavaScript runtime is probably too large to actually run on the microcontroller, and they're probably talking more about sending messages to it rather than actually running on the microcontroller. Does that sound?
That sounds reasonable. So I know that for a long period, I think mainly with this Node.js, so I'm not a real JavaScript expert, but now, of course, everybody knows Node.js, and the standard implementation was usually that people build small little microcontrollers, and they still write that actually in C, but then have an HTTP API to the cloud, to a web server, and provide actually on the web server some JavaScript backend where people can actually do the logic. So the microcontroller will actually outsource the logic into the cloud. So this was in the past, but as a matter of fact, there are actually JavaScript implementations now which are similar to MRuby, and there's even something called MicroPython, which is actually a Python implementation, which has a similar approach as MRuby. So this is a market which grows quite dramatically, especially because most people do not want to develop C. We will probably talk a little bit later about some of the huge disadvantages of C. And microcontrollers are historically always being programmed in C or even as in assembler. So with Arduino, it's more like C++, but it is still horrible. So there's a huge community who wants actually to move to languages they know from the web environment. They feel more comfortable with it. There's a big move. So in the past, I think most of this JavaScript was done server-side, but it's also coming to microcontrollers slowly.
Right. So it seems like a lot of people who kind of grew up learning scripting languages like, say, Ruby or Python or JavaScript, they're actually going to potentially be able to use those in areas where, like you said, people used to use C. So I think that's going to be a really a powerful thing for people to get more people involved in working with microcontrollers or working with low resource devices. So I think that's really exciting.
Yes, I agree. But now to be now very fair about microcontrollers is maybe a little bit a direction which I'm very focused on. So this is one of the main reasons why I'm interested in MRuby. But a huge use case of MRuby is actually not only microcontrollers, but actually using MRuby and embedding it in existing applications. There are also the sizes plays a whole role. And I think that's at the moment the bigger use case actually for MRuby, that people take MRuby and put it into existing applications. So a use case would be, for example, a game engine. So you develop your game usually also in C++ for the graphic performance stuff, and then the storytelling, for example, is being done in a scripting language. And in the past, often Lua was used for that. And MRuby also started as one competitor to Lua, to replace Lua instead of as this game scripting engine.
So you mentioned that the typical usage of MRuby, or maybe the reason that it was created, was actually originally to embed into, say, C programs, like you said, with game engines and embedding into another application. So what is different about MRuby where it's able to do this where the traditional Ruby implementation is not?
Okay, so the first and foremost reason is definitely, again, the size, especially of embedding something into existing application, the RAM. So if you, for example, spawn several instances of a standard MRI inside of an existing C application, which is possible. So you can also use MRI to embed into C applications. You will consume a huge amount of memory. And the use case for a lot of companies is that they actually want to spawn a lot of instances and give maybe each customer or each playing character in a game an own instance of MRuby or of Ruby. And in this case, it makes a lot difference if you consume per instance 100 or 500 kilobytes of RAM, or if you're actually consuming 10 or 20 megabyte of RAM in case of MRI. So this is number one. Number two is you can limit the functionality of MRuby when you give your users the possibility, for example, to edit code inside of your C application. So you write maybe a C application and you give the user the possibility to actually script your program in Ruby. You do not want to give your user all rights to the whole feature set of Ruby, like, for example, to execute something on the shell or open and close files or delete the file system. So MRI essentially does not offer this functionality that you can remove these features. You could, of course, manipulate the source code. It's open source, but it's very cumbersome, and it will break most of the time the interpreter. MRuby is designed to actually remove every single part individually. So you can create an MRuby interpreter which can only do, for example, class definition, arrays, and strings, but it cannot do open files. It cannot do shell access. It cannot do network access. That adds a little bit to the security now of using Ruby in areas where you usually would not like to give the user too much power.
Okay, so if I understand correctly, you can actually, in a way, you're making your own subset of MRuby by being able to remove specific functions that you would deem unsafe to allow other users to use. And in that way, you can kind of really control people's usage to make sure they only use it in the way that you intend. Is that correct?
Exactly. That's actually probably the best way of explaining it. You can make your own custom Ruby.
Mm-hmm. And you also mentioned that the RAM usage of regular Ruby is much higher than MRuby. I've also noticed that Ruby in particular is challenging to bundle in a standalone fashion. And there's projects like Traveling Ruby that include a precompiled Ruby interpreter. But I've heard there are many issues with doing this, like dependency on C extensions and things like that. So
Yes. So one of the biggest thing is, first of all, that MRI works by default very badly on Windows. It works, and we have actually several people who work very hard to make MRI properly run on Windows, but it is always some kind of pain. And if you make these, I do not know how to call it, maybe bundled or in one-click executable, So where you do not have a script like you usually have it in Ruby, you have a text file which you execute with an interpreter, but just one exe executable, which runs on Windows or which runs on Linux or Mac OS X, then this is very cumbersome to do. In MRuby, we actually have a fairly complex cross-compiling infrastructure, which was developed sometime by me to actually support all different microcontrollers, but which now actually gives the benefit that we can also compile specific executables for Windows, Linux, Mac OS X from one source. So you actually compile an individual executable which contains everything you need to run Ruby and not more. So you can actually create an executable which is just 0.5 MB, and it contains not only the interpreter but also your source code you actually want to execute.
Angular, React, Vue, Knockout. The forecast calls for a flurry of frameworks, making it hard to decide which to use. Or maybe you already have a preferred JavaScript framework, but you want to try out a new one. Wijmo and Grape City bring you the How to Choose the Best JavaScript Framework for Your Team ebook. In this free ebook, you'll learn about JavaScript frameworks. You'll learn about software design patterns, and you'll learn about the advantage of using frameworks with UI libraries like Wijmo. You'll also learn about the basic history and the purposes of JavaScript's top frameworks. You'll also learn how to integrate a Wijmo UI control in pure JavaScript and in some of the top JavaScript frameworks that we've already talked about, like Angular, React, Vue, and Knockout. Wijmo's spec method allows you to determine which framework is best suited to your project based on your priorities. So whatever those priorities and your selections are, you can learn how to migrate to a new framework in this ebook. Best of all, this ebook is free. You can download your copy today to help choose a framework for your work at softwareengineeringdaily.com/grapecity. Thanks to Grape City for being a new sponsor of Software Engineering Daily. You can check out that ebook at softwareengineeringdaily.com/grapecity.
Right. So I've noticed that from what you're saying, it seems like MRuby is very suitable for providing command line applications, because I've noticed that, for example, Heroku, their command line toolset, it used to be implemented in Ruby, but they mentioned that they had a lot of problems. Like you said, on Windows, it's very challenging to deploy a Ruby binary. On other operating systems, you don't always know what version somebody has of Ruby. And
yes, so there's this project, if I recall it right, MRuby CLI, I think, which is done by one guy from Heroku and actually another MRuby committer. And they want actually to create these CLI applications in Ruby, but immediately executable no matter where they are running, even if there's no Ruby interpreter available. So there's one reason is for portability. Another reason is also for starting speed. So MRI itself is actually not that slow to start up, but as a matter of fact, JRuby, a lot of people complained always that the JVM, of course, has some boot up time. And as a matter of fact, there is even a project where MRuby is used to speed up the starting time of JRuby. So there's one small project where they made a small little CLI applications to bootstrap JRuby, which they did in the past in a different way, in a much slower way.
Interesting. So it's almost like the different Ruby implementations are supporting one another in some way, which I find pretty fascinating.
Yes, so yeah, there's definitely the use case. So MRuby will not replace MRI and also not JRuby, and neither the other way. So everyone has its niche. So I started a little bit off-putting in the beginning that they are a little bit big and clumsy, but there's of course a reason. So MRI, for example, is the only Ruby implementation from my perspective who can really do all of Ruby as I understand Ruby. So JRuby is the closest competitor, which is maybe 99.99% compatible. There are some niches where it's not, and I remember they worked quite hard to actually get all the C bindings running, but there are some cases which they are not 100% compatible. That's most of the time not an issue, but now for some people it might be. But on the other side, they're providing this high performance JVM, which is maybe for some people surprising because most people associate Java with slowness. But as a matter of fact, if you have the JVM running for some while, the JIT is actually now starting and speeds up JRuby quite dramatically. So for high performance web applications, I hear very often that people at one point switch to JRuby to get some additional performance.
People's perception of Java being slow, I think, maybe comes from a lot of Java desktop applications that in the past were
Swing and
that were that didn't look native or had a very awkward UI, and there was also the Java applets that used to run in the browser. So I think from a marketing perspective, they had some challenges there, but the JVM is actually most likely it's the most advanced language VM I think that's out there.
Definitely, especially concerning the garbage collection. It's amazing what kind of algorithms they're providing there, which are actually switchable. So most people actually do not know that. So nothing bad about the JVM. It's an amazing piece of software. I just do not like Java, but the JVM itself is an impressive piece of technology.
Right. I think next what I'd like to move into is to talk a little bit about Shopify. And so Shopify is they make a product that allows users to create custom storefronts. And what initially got me interested in this topic was their use of MRuby and the bug bounty that came out of that. So first off, can you sort of explain how did Shopify make use of MRuby and what made it a good choice for them?
Okay, so I'm not a Shopify user, but as I understand, the Shopify concept is that they have the software as a service concept that you rent a shopping infrastructure at their place. So you can maybe, if you like to sell t-shirts, then you can use their shopping infrastructure, and they are handling all the complex stuff like the merchant and the shopping carts and all this infrastructure. And some time ago, they provided a very interesting addition, which is, I'm not sure how they call it, Shopify scripting engine or something like that, where they actually provide the possibility that you can add Ruby code to your shop and do some custom things. So you can not only click how your shop looks, but actually you can program how your shop reacts. So one example they are giving is that you can make some discounts. For example, if you put something in your shopping cart, then they trigger some Ruby scripts, and then you can do some own custom magic, like saying if you shop 2 elements, then you get 1 for free or something like that. And there they're actually using MRuby, which I also learned quite late, as a matter of fact. Yeah, they had at one point a feeling they should maybe have a look about the security of running Ruby code on their servers, which is a good idea.
Yeah, and I think what happened next was fairly remarkable. So they opened up a bug bounty for MRuby through HackerOne. I guess one thing I would ask you is that, were you surprised when they opened this bug bounty? Has there been any precedent for any corporate backing for MRuby?
No, I would not call it corporate, but there was a government funding. So the original MRuby project started from, don't let me lie, but I think it's the Ministry of Economy and Trade and Industry of Japan. So they sponsored the first activities to implement MRuby. But next to that, there was no financial addition to MRuby. There were several companies, mainly from Japan, implementing things, but it was not like they giving money out to find someone implementing something. So it is for MRuby, it was quite new precedent that a company stand out and say, we are willing to put money into MRuby if you help us improve it. So that was quite impressive. So there's of course examples like that for other projects. So for example, Linux kernel is big fashions and developed in this way. But for MRuby, it's the first time.
So that's great, because in a way it almost legitimizes or kind of shows that like companies are so interested in MRuby that they're willing to invest into it. So I think that's a really exciting event for MRuby.
Mm-hmm. So I think what pushed actually MRuby, it's my guess. I'm not part of Shopify, so I do not know their internal strategies. But what makes for me sense to explain that actually was that Shopify is, to my knowledge, also developed in Ruby itself. So I think it's even a Rails application. And Shopify developed quite early a gem. So the package manager from Ruby is called Ruby Gem. And you can write small gems to add functionality to MRI. And what they actually did was to build such a package to integrate MRuby into MRI. So and now it gets a little bit meta, because you can now run a Ruby program, and inside of the Ruby program you can execute Ruby, but the Ruby code you're executing inside of it will be executed by MRuby. So you have the protection and the limited function set of MRuby. And that makes a lot of sense for them, because they are developing their whole shop infrastructure in standard Ruby, and their customers, they're giving a subset of Ruby to now modify their own shop. So here again, the Ruby ecosystem helps itself to grow. It's very neat. And at one point, they apparently noticed, okay, we are now giving our users the possibility to put code into our system and execute that on our machines. And obviously, they're having a lot to lose. I mean, we are talking about a shopping system which handles money, which has to protect their customers and merchant. So it was then, from their perspective, probably quite reasonable to say, okay, we have to make a security audit. And apparently the security audit went public from their perspective, because you could also have imagined that they make that internally. But they probably believe that it will be cheaper if they outsource it.
In terms of the bug bounty, you mean?
Yes.
Yeah, so that actually takes us to HackerOne. So HackerOne is a bug bounty platform that connects businesses with cybersecurity researchers. So the question I was going to ask is why would a company use HackerOne versus internal security reviews or security consultants?
Mm-hmm. So I, of course, cannot speak for Shopify. I do not know their internal reasons. I can only guess. But from the company I'm working for, we are also making security audits for safety-relevant stuff. And we also ask people, I mean, our company is big enough. We have actually a specific department for that, to come to us and look at the code. But I believe it should always be outside from the development team who actually has developed it, because these people will always look with fresh eyes on the infrastructure and will also try things developer would say, no, you do not use my application in this way. I think developers testing their own code is a very bad idea, and the same goes for security checks. I mean, in the end, a security issue is also just a software bug. Sometimes with a little bit more press behind it, but in the end, it's a software bug, and it should be handled in the same way as software bugs are handled, testing it. And if you want to find completely new concepts of breaking a software, it makes a lot of sense to look with new eyes on it. There's a lot of security researchers actually out there, so I'm not really active in the scene, but in the past, apparently, they were mostly paid maybe by finding bugs and selling them to some people who might use them to build malware. But these days, actually, a lot of companies actually provide money, which is great. So these people can actually be legal and at the same time provide some beneficial service. So there seems to be a huge community who actually searches bugs and gets a payment for that. It's great.
Right. Toby, the founder of Shopify, he made a post on, I believe it was Hacker News, where he said in a way, so Shopify, because it's dealing with storefronts, security is really, really important, because they basically host the livelihoods of hundreds of thousands of other businesses. And so part of their interest in HackerOne is actually they wanted to sort of spend as, of course it was to address the security vulnerabilities, but it was also to sort of be known as a company that will pay well and make it easy for you to work with them if you're in the white hat community. So I think this was a way to, as you said, get them exposed to the much wider security community outside of their company.
Well, they definitely have proven that. I mean, do we want to talk about the amounts of money they have paid out?
Absolutely. Do you have the numbers?
Yeah, approximately. So I didn't check lately, but I think approximately last value was around $518,000 US dollar. So more than $500,000 US, which is quite impressive.
That's a lot of money.
Yeah, of course. It's amazing. So if you think that a company is willing to spend that much money in a software project, it seems to be really valuable for them. I mean, of course, there's some bad mousing. Maybe we should also mention that shortly, because the blog entry I have written about this was going into detail, and I got actually a lot of bad feedback about that. But I think it's important to mention that they started with a bug bounty prices per bug from $1,000 for a very tiny bug, which maybe crashes the VM but doesn't really put any security risk to the system, up to $20,000 per bug, which actually compromises the security. So this is what I started with in November last year, 2016. And I remember 1 month later, they already have paid out several hundreds, thousands of US, because people really found a lot of bugs. It's of course for me as someone who has worked on the software a little bit tragical, but I'm happy that the bugs are found. It's on the other side also a little bit depressive that there are so many bugs. And after this 1 month, they said, okay, we are now actually sandboxing the whole system. So what they did is that they put MRuby into a sandbox and used some of these security mechanisms and capability features of the Linux kernel to protect MRuby a little bit more and capture most of the security bugs. And they also limited the amount of bytecode in instructions you can actually execute. And I remember also they limited the runtime. So they did a lot of things actually to compensate for the amount of bugs. But even though that they then reduced actually, I think, from 20,000 to down to 10% for each bug. So instead of 20,000, you got then something like $2,000, which is still impressive for, to say the least, for a security bug. They keep the HackerOne still open. And this is actually one thing nobody should forget, even if a lot of complaints were going around that a lot of the security people do not believe in sandboxing. So they said, okay, this is not the right way of solving the problem. But as a matter of fact, they keep the security bug bounty open, and they're still paying out until today. So we still get new bug reports in, and we are still fixing them. So they're still paying money out, which has to be definitely appreciated from them. So it's a very impressive contribution from them.
Yeah, I think that's great because it sort of shows that they are committed to using MRuby, and they want to make sure that it continues to be an active platform and a secure platform. So I think that's almost like a vote of confidence from them that they intend to continue using it.
One of the big advantages I hope now, which comes out of that, is of course that after Shopify has now invested so much and made MRuby somehow more secure. I do not want to say that it's now secure. There's for sure still bugs which will be found, and there will never be no bugs available in MRuby. There will always be bugs, but it is certainly more secure today than it was half a year ago. And I hope with this investment that also a lot of other companies are now looking at it and saying, okay, I could use this embedded language or this embedded language, but actually MRuby has now invested so much time in actually concentrating of security fixing that it's probably the best choice to actually use MRuby because so many people have already looked at it.
Right. So like you were sort of mentioning before, there were some people who were maybe upset when they saw like the number of security issues that were reported. But in a way, if security issues are not reported, it doesn't mean that they're not there. So that,
no, of course not.
Right.
It is just a personal, so my heart hurts every day when I see that there's another report. But no, I'm very glad that they have reported. You are absolutely right. We cannot close our eyes and just hope that nobody use our tooling and then no bugs are found. So the bugs are there no matter what. And it's great that someone found it and reported them.
Right. So I think this is not something that's limited to just MRuby. I think this is something, and we'll maybe talk a little bit about this later, but anytime there is a language that does not have a lot of corporate backing or a lot of users, let's say new languages, like say Elixir or Crystal, things like that these are things that maybe people don't always think about, that because people are not actively searching for security issues, there may be security issues in these other younger languages as well. So I think this is good to build awareness of things like that.
Yes.
So So related to that, before the bug bounty was put into place, how often were MRuby security issues reported by the community?
That's a tricky question because, as a matter of fact, I do not recall a single one who came and said, this is here a security bug, I can compromise something. There were, of course, a lot of bugs were reported over the last 5 years, and a lot of them were also some starting points for possible compromisation of wide escalation or code injection. But as a matter of fact, nobody reported them as security bugs. People reported it as heap overflows, buffer overruns, but not in a security context. So actively, nobody started to really look at security issues until Shopify started this activity. And now, if I recall right, so I also don't have the latest numbers in my head, but the last time I counted, we had 200 reported security bugs. And I think at the moment there are 2 or 3 left open, which were just recently reported. But all these 200 bugs were actually now resolved and integrated.
So I think that kind of brings us to our next topic of what are sort of the most common vulnerabilities that are found as a result of the bug bounty, and how are these vulnerabilities triggered?
Okay, maybe 2 things. So I actually had a look because I was also very interested at how much of my code was affected. So I made a statistic, and approximately, I think it was a little bit more than 90%. I actually made a count on my blog of all security bugs were actually found in C code. So the most often error is manual memory management. So this is the number 1. So that leads to different things like invalid pointers, heap overflows, null pointer dereferences, memory corruptions, double freeze, heap use after free. So all these standard bugs, which happens because C requests the developer to handle the memory management. And I think less than 5% of the bugs were actually found in real Ruby code. And that's quite impressive if you looked at approximately a little, not 50, but not too much away from 50% of all MRuby code is actually written in Ruby itself. So you have this not completely, but close to 1:1 ratio from C to Ruby. But most errors were, so the majority of the errors were found in C code. So it was a very clear indication for me that where to optimize, get rid of the C code and try to rewrite as much as possible of MRuby in Ruby itself. That's nevertheless our target since day 1.
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to support Software Engineering Daily and get a free t-shirt. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. It is only with the help of sponsors like you that this show is successful. So thanks again.
So this code that you would propose rewriting in Ruby, is this more things like that are built into the standard library, or because
Yes.
I imagine because things like the virtual. Oh, go ahead.
Oh, sorry. So one thing we of course have to remember, as much as I like Ruby, but using Ruby is always defeating one purpose of MRuby, and this is increasing the interpreter size or the virtual machine size. So the more Ruby code we write, the bigger the Ruby implementation will be. Of course, we can never be as efficient as pure C code. So the parser, the virtual machine, the garbage collector, all these things will stay as C code for these very reasons, because we want to keep the core small. There's actually a project called Rubinius, which targets to write a whole interpreter in Ruby itself, but this is not our target, because it will increase the size. So what we are mostly focusing is of writing as many parts of the standard library and even parts of the core library in Ruby. And this is, you actually can see that quite easily in the source code these days already, that a lot of parts of the string libraries, the arrays, the hashes, mostly of them are actually implemented in Ruby.
So the vulnerabilities that occur, you were mentioning it was things like null pointer or heap use after freeze. So these are all sort of related to manual memory management.
So first of all, yes, there were, of course. So I do not want to downplay some of the other bugs. So there were, of course, real logic errors. So in Ruby, we cannot have these kind of bugs. So there's no manual memory management, but still we can have bugs. So specifically, you can trick the interpreter by having very deep stacks. That's a general issue with languages. And there were several bugs reported of crashing Ruby or bringing it to a hold state by making some construction which run forever. And some other examples were that the data structure, which is actually written in C, could be shifted from some very smart allocations of Ruby objects. So I don't want to go into detail, but the data structure in Ruby is very, very simple. So you have a data structure and you have the data itself, and then at one point identification what kind of data object it is. So you have maybe a string information, hello world, and then at one point in this data structure there's an identification what class this data type is. And there was actually one very impressive bug, I have to say, where someone noticed that I think it came from a string. So he started to build a string. Then he deallocated it and allocated an array again. And with that, he could actually change the type of the data structure, which can lead to very, very, very scary effects in the interpreter. So these were actually bugs accessible via Ruby. But the core issue was not memory management, but logic errors. So these bugs are also available. So I do not want to blame C only. There were also just bugs where we did not consider. Also bugs like these by one errors, that you have some loops and you have miscounted yourself and one element too long or one element too little.
Right. So the example you were giving, just so that I understand correctly, it would be as though you created a new object that you told Ruby was a string, and you were somehow able to convince Ruby that the object at that memory location wasn't really a string, it was actually some other data type. And so that would kind of create non-deterministic behavior within the runtime.
No, well, it will always be deterministic, but not in the way that it is expected.
Right. So
yeah,
just
yes, you're absolutely
unexpected
right.
behavior.
Yeah. So this is a very funny one, and I was really impressed when I saw it the first time. And as I said, I'm not a security researcher. I know very little about this field, and I was a long time scratching my head. How did they find something like that? I mean, again, I do not want to blame. I'm very happy that they found it, but I could not understand how they were able to find it, because my understanding in the past was always, as a security researcher, you would maybe look at source code and look at standard problems like memory allocations, and then maybe figure some edge cases in the source code and then poke this use case a little bit more. But this kind of bug, like I explained just now, and they had several of them, you could not find in that way. It was really mind-blowing to me. And till I noticed that they actually use these days very advanced fuzzing mechanisms. So most of these guys actually have some very smart fuzzing tooling chain, and actually played around with some of them. And it's quite impressive what you can do these days automated. So actually parts of the security community even automated their own job. It's quite impressive.
So can you elaborate a little bit on what you mean by fuzzing and how these security researchers are discovering these bugs without, I guess, actually reading the source code themselves?
Okay, so maybe I'll start shortly from the beginning. So my understanding, and this is how we did with some of our teams in the past was that we really reviewed source code. So you could a long time use things like Wallgrid and identify some hotspots where it's worth looking at. But in the end, you would look actually at the source code, follow the structure, and make some assumptions where the developer didn't really sort to the end, and then try to poke that from the outside. And I think there are some strategies now where people actually look permanently on new commits. So they just subscribe to the Git repository, and then they'll always look what kind of new commits are coming into the source code, and then they have a short check. Did the developer did something stupid, obviously, here. So that's a very obvious thing. But as a matter of fact, since several years, they went away. And I mean, fuzzing, I think, is a term maybe known for several people. So the idea that you start a program and just feed it random stuff in the beginning. So, and I tried that a long time ago, and I was not really ever convinced that this concept makes a lot of sense. It can find some very stupid bugs, but it cannot really find real complex things. And as a matter of fact, are now some toolings. So one very famous one is this American Fuzzy Lob, which is a fuzzer which you give some inputs. So you define some example Ruby code, and then this fuzzer is feeding the software you want to test. And one important thing is that you actually compile the source code you want to test with a GCC add-on from this fuzzer. And then this fuzzer is able to actually track the code path. So it can feed code, and then it can look, okay, where's my code path going into the software? And then it modifies the input, and then it looks, can I come further? Can I reach new code paths with this modification? And if no, then I try something new. If yes, then I start to mutate on this change. And with that, you can actually slowly find your way to corner cases, edge cases in software, which are very rarely tested. So there's AFL. So if you check actually their website, they have a quite impressive rate of bugs they found. So essentially, you have to give them some reasonable inputs, and then you just give them a lot of CPU power. So actually, there are some fancy optimization, but essentially what you try to optimize is to execute, in our case, the MRuby interpreter as often as possible. So I actually created for my own test some small optimized interpreter, and with that I can something like 60,000, I remember, calls to the interpreter done per second, and then it will, I think I let that run actually over Dragon Boat Festival, and it found, so it tried something like 7 billion different inputs and found out of that approximately 2,000 ways of actually crashing the MRuby interpreter.
Oh, wow.
And out of that, I mean, then you have this number, and I actually tried it because I wanted to see the differences between the MRuby 1.2 now version and the one we're having now. The interesting thing is the crashes. At the beginning, you are shocked immediately and say, there's still so much after all this improvement, but then you actually look into it, and then there are a lot of false positives. But you actually find some ways of tricking the MRuby interpreter still today if you just take the standard configuration. So there are just some things you cannot avoid, like endless loops. If you do not limit the interpreter, you can always, of course, create a denial of service. So you have to take that always into consideration. And Shopify did that, of course. Yes, but it's a very impressive tooling. So I would suggest everybody who builds some kind of software which is actually accessible by any kind of unknown users to give AFL a try. I mean, that's not a complex tooling. In the beginning, I was a little bit hesitating because I really do not know anything about security research, but you can get started with it. Of course, really getting a lot of value, and you should know what you are doing. And if you know the source code, that helps already tremendously. And having then this tooling additionally, you can at least get some first information.
Yeah, I think that's fascinating. I mean, I think if I understand correctly, you give what was the name of the application you were using?
It's called AFL, so American Fuzzy Lob. But I think if you search for AFL, you usually find it AFL and fuzzing.
So if you use this AFL, you basically give it a sample application that takes inputs, and AFL can actually just send in as many types of inputs as it can, just to sort of see where it can get inside of your implementation.
Yes.
Is that okay?
Yes. So
Yeah, that's
the feeding can be more and more complex. So a lot of the security researchers, I looked at some of their GitHub repositories, they actually just used some random source code. I optimized the source code I feed it with, and you can also actually teach AFL a little bit about keywords. So things like, I think an easier example would be SQL. So they actually use AFL to check SQLite. And there you could, for example, define specific keywords which are used in SQL, like select, like insert, and then AFL can with that arrange the combinations in a little bit smarter way, so it can essentially guess a little bit smarter. And the same you can do, of course, with Ruby, even though that Ruby syntax is, I think, by far one of the complexest at all from all programming languages. So I actually used our parser J to extract all the keywords, and with that you can actually improve the performance of AFL to find better tooling. But even just starting randomly with it will already bring you quite far.
So I guess the dynamic languages like, say, Ruby and Python and JavaScript, just because there are so many more valid inputs, there's so many more opportunities for AFL to find issues. Is that correct?
Yes. Even though that I would always claim that the complexity of Ruby specifically is extreme. I mean, a lot of people maybe know that Ruby's syntax can be quite awkward, but most of them have no idea how complex Ruby's syntax is actually. So if you look at the parser J of Ruby, it's something like 6,000 lines of code. And as a matter of fact, all Ruby implementations more or less base their interpreter, so their parser, on the same parser J, which was written for MRI, because nobody dares to re-implement this parser. So this is one thing what makes Ruby specifically very, very interesting target, because there are so many possibilities and a lot of them might never have thought by the developers.
And this parser, is it written in C, or what language is it written
Yes,
in?
It depends a little bit. So our one is, of course, then based on Bison together with C. So you essentially generate a parser based on a predefined language. So that's a normal way. So that's not very specific to Ruby. Most programming languages have that. So there are some other parser generators like AntLR or Yak. So you have this structure. In our case, this famous parser J file, and it contains, in our case, some C code and some declarations how the C code is used inside of the parsing in the grammar. And then it actually generates C code to parse. And for example, JRuby interpreter would then not generate C code, but Java code, for example. And Rubinius infrastructure will then generate actually Ruby code.
Mm-hmm. So I guess in terms of, so Ruby was really built behind this concept of developer happiness, and kind of, in a way, it feels a little bit like writing pseudocode. So that's a reason why there's a lot of developers who enjoy using Ruby. But it sounds like in the efforts to make a language that's friendly for people to use, it ends up being almost a bit of a nightmare for the language interpreters. Is that fair to say?
That's absolutely fair to say. So the target of Ruby is always to let the computer work harder than the developer. So some things people would say, well, why do you do that? So there's specific things like length and size. So quite often you have, for the same logic, two different ways, or even more than two different ways of saying it. Another example is this famous if statement. So in Ruby, you have also the unless statement. So instead of saying if not, you say unless, which the Python developers usually would put their hand on their head, because, well, why? It does not make sense. I just use a not, but it's a very different way of looking at problems, and it fits personally my mind very nice, because I think I do not believe in one size fits all or one right way, and this is definitely how Ruby proceeds. Ruby gives you the freedom to write your code in a very Perlish way. There's even actually a so-called golf mode in MRI. Few people actually know that. So code golfing is sort of the art of writing very compact code, which makes amazing things. And Ruby has actually a golf mode to actually make even more compact code, which you cannot read anymore. And actually, I think one of the MRI Ruby committer is one of the strongest golf player because he's using Ruby. And on the other side, you can make very elaborate code, like Rails is a very good example. You have these, so I'm not a Rails developer, but there are these have database table XYY, and you essentially nearly write English language, and you create these domain-specific languages specifically for something. Also, one famous thing is this RSpec or this behavior-driven development, where you actually write also in close to English code to test and specify Ruby code. So everybody, independent if he can read Ruby or not, he will understand what is written because it is plain English. So there's quite a flexibility, and I like that Ruby gives me both ways. So I can start to hack away a first prototype, and most of the time I throw it then away, but I have then the possibility to iterate over this code and improve it to something which is actually maintainable. I mean, there's always this claim that Ruby is not maintainable, but I hope that people slowly understand with projects like GitHub, GitLab, Taobao, Basecamp. So there are so many use cases where they have a huge code base, and you can manage it. You just have to stop believing that the compiler will save you. You have to protect yourself with unit testing and behavior testing.
Right, and I think that Ruby's syntax and the way the language has been designed, it's really lended itself to teaching people who are new to software development, because we see a lot of programming boot camps teaching Ruby. We see a lot of outreach programs that are trying to show people who are new to programming, get them some exposure to it. And oftentimes these programs use Ruby to demonstrate that. And I think it's a combination of the Ruby community itself, but also, like you said, the way that Ruby allows you to think in different ways with something as trivial as, say, being able to say unless rather than just if. I think it's little touches like that make it unique.
It's a stupid example, so that's really one of the very small ones. I mean, the more fancier things is that you can actually look at your code in a procedural way or in a functional way. So Lambda constructs are very powerful in Ruby. If your mind is built to think functional, you can actually come quite far. It's so this if unless is just something most people always mention, but it's just the tip of the iceberg.
Right. So I guess you would say in some ways it supports multiple sort of ways of looking at a problem, whether it's object-oriented or functional or something else.
Yes. So I'm even looking at one problem at the same time with different aspects. So if I have data structures, of course, I might prefer an object-oriented way. But if I look at an algorithmic problem in a bigger context, I want to solve that functional. And if I want to write some glue code for some applications, which is something I do all the time, I might actually prefer a procedural way because I just want to have a one-time use of a script and then throw it afterwards away. So I do not want to be actually handling all this boilerplate, which is usually necessary.
So it allows you to work at sort of whatever level of complexity that you decide to use for the given project. So we've covered a lot, everything from MRuby to the bug bounty program and Shopify to the vulnerabilities that were found within MRuby and kind of how those relate to other languages as well. Is there anything else that we missed that you'd like to mention?
Well, probably a lot, but I think we covered a lot. So I think maybe as some, not closing comments, but maybe as an outlook. So the last version of Ruby was 1.2 already more than a year ago. So we actually had a plan to release now the 1.3 version of MRuby, which has a lot of features actually included in this March. But as a matter of fact, this Shopify bug bounty actually crossed our targets there a little bit because we said if they are now investing all the time, we are not going to release a new version which has obvious security bugs, and then we would have immediately to put a new dot release. So we postponed it from March to April and said, okay, when we have fixed all the Shopify bugs, then we will release. But yeah, as I said, they were coming and coming. And at the moment, I think there are still, 3 or 4 bugs open. So our plan would be to very soon actually release 1.3 release of MRuby, which then is a new baseline, and then we are starting on adding these keyword arguments to MRuby, and we'll work further on the stability and of course security bugs. So if someone finds security bugs, I hope they're reporting them to us.
Great. So we'll all look forward to the next release of MRuby 1.3. I just want to thank you, Daniel, for taking the time to speak with me today, and we look forward to seeing what you come up with next.
Okay, it was a pleasure. I hope it was interesting.
Definitely. I think there's a lot of interesting material that our listeners are going to enjoy. So thanks again for coming on Software Engineering Daily.
Okay, bye-bye.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!